Here we have AP calculus AB problem. Okay, let's go to the question. The first derivative f prime of a function f is given by f prime of x equals to 1 over 2 negative e to the negative x bar, and which of the following intervals is f increasing? Okay, among the given answer choices, we have to find the interval where the given function f is increasing. Okay, whenever I want to find the interval of increasing or decreasing for a particular function, so usually you'll find first derivative, but we don't have to do that. It's already given. The first derivative is given. Okay, using the first derivative, first we have to get the critical numbers. Okay, how do I have to get the critical numbers? Let me write the derivative of the given function, that is f prime of x equals to 1 over 2 negative e to the negative x bar. Okay, before I start finding the critical numbers for the function f, let me do some simplification over here. There is some adjustments. Let me write f prime of x on the left side as this 1 over 2. Okay, now we can write this e to the negative x bar as 1 over e to the x bar. Okay, f prime of x equals to, okay, now if I want to do subtraction between the two fractions, I must be getting the same denominator for both the fractions. What should I do? Here I have to multiply both numerator and denominator by e to the x power, and here I have to multiply both numerator and denominator by just 2, so that I'll be getting 2 times e to the x power as a common denominator. Okay, when I multiply both numerator and denominator by e to the x power, I'm getting e to the x power divided by 2 times e to the x power. And here I have to multiply the numerator and denominator by 2, then I'm getting 2 divided by 2 times e to the x power. Okay, now I got the same denominator for both the fractions, so we can take the 2 times e to the x power as a common denominator. In numerator we'll have e to the x power negative 2. Okay, now I got the first, actually the first derivative is given. I've done some simplification over here in this stuff. Okay, now always we have to follow two methods to get critical numbers for a function. One is I have to equate the first derivative to 0 and solve for x. So the second method, that one also should be followed. So we have to find the real value of x for which f prime of x is undefined or it does not exist. Okay, let me use the first method to get the critical number. That is, I have to equate the first derivative to 0 and solve for x. So when I equate this first derivative to 0, so then this stuff is also equal to 0. That is e to the x power negative 2 divided by 2 times e to the x power equals to 0. Okay, now let me multiply both sides by 2 times e to the x power to get up the denominator. Let me do it, 2 times e to the x power. So this one will cancel out. Then I'm getting e to the x power negative 2 equals 2 on the right side. So when I multiply this stuff by 0, it's still 0. Okay, let me add 2 to both sides. When I add 2 to both sides, there's negative 2 positive will cancel out. We have e to the x power equals to 2. Okay, now we have to solve for x, that is at the exponent. Actually, this equation is in exponential form. If I want to solve for the variable x at the exponent, I have to convert this equation to logarithmic form. How do you have to convert this equation to logarithmic form? For that, we have to consider the term which is exponential. So this is a term being as exponential over here. In this term, just move the base alone to the right side of the equation. When I move this base e to the right side of the equation, it will become log to the base e. So for a logarithm, if the base is e, it will be considered as a natural logarithm and we write it as ln. And the value which already exists on the right side will become the argument of the logarithm. So when I move this base alone, this e to the other side of the equation, it will become a logarithm with base e. So logarithm with base e is called natural logarithm. It will be written as ln2. And the exponent we have over here will become the base on the left side. Okay, now I have solved for x by equating the first derivative to 0. So this is a critical number. And also I said we have to follow two methods always. So I just follow the first method, that is I equated the first derivative to 0 and solve for x. The second method is I have to get the real value of x if possible, for which f prime of x becomes undefined. Okay, here when I consider the stuff we have here for f prime of x, so it's in the form of a fraction. If the denominator becomes 0, then f prime of x will become undefined. So now we have to check whether there is any real value of x for which the denominator becomes 0. No, because this denominator e to the x power will become 0 when x is negative infinity. So only when x takes negative infinity, it will become 0. But 2 will now become 0. When this one becomes 0, it is multiplied by 2, the denominator will become 0. So this part will become 0 when x takes negative infinity. So there is no real value of x for which f prime of x becomes undefined. So there is only one critical number I am getting following both the methods, that is ln2. Okay, now let me mark this value ln2 on the number line. On the left side extreme we have negative infinity, on the right side extreme we have positive infinity. Okay, writing this critical number ln2 on the number line, we get two intervals. One is negative infinity comma natural logarithm of 2, and the other one is natural logarithm of 2 comma positive infinity. Okay, now we have to check each of these two intervals. with the first derivative. The simplified form of first derivative. So for example, let me take a random value in the first interval and plug in for x into the first derivative. If the first derivative is greater than 0, then we have to say the given function is increasing in this interval. In case in this interval, when you take a random value and plug in for x, if the first derivative is negative, that is less than 0, we have to say the function, the original function f of x is decreasing in this interval because the slope is negative. Okay, now let's take a random value in the first interval between negative infinity to ln2. So that's ln1. Because here the argument is 2. When I take a value on the left side of ln2, it will be less than this one. So we can take 1. In a logarithm, if the argument is 1, its value is 0. So ln1 or 0. Both of them are same. Okay, now what we can do is we can plug in this 0 into the first derivative over here. Let me do it. F prime of 0 equals to e to the 0th power negative 2 divided by 2 times e to the 0th power. The value of e to the 0th power is just 1, 1 negative 2, and the value of this e to the 0th power, anything raised to the 0th power is just 1, 1 times 2 is 2, then we get f prime of 0 equals to 1 negative 2 is negative 1 divided by 2. Clearly this is a negative value, that is less than 0. So when I take a random value in the interval negative infinity comma ln2, the first derivative becomes negative. So the function f of x is decreasing in this interval. But our aim is to find the interval of increasing. For that, we can consider a random value in this interval between ln2 and positive infinity. So now let me take ln3. So here the argument is to get the value on the right side, which is greater than this one. So let's increase this value 2 to 3, ln3. Now let's plug in this ln3 into the first derivative over here. Okay, let me do it. I'm going to plug in this one. That is f prime of ln3 equals to e to the power of ln3. That is, I plug in ln3 for x over here. Negative 2 divided by 2 times e to the power of ln3. Okay, so here actually when I plug in this 0 for x over here, I got e to the 0th power and I got the value of this one easily, that is 1. How do you have to get the value of this one and this one? For that, we can consider an important property of the logarithm, that is, let me consider base x and the exponent as a logarithm with base x, that is a. Okay, here let's consider the power. The base over here is x, and the base of the logarithm at the exponent is also the same x. So whenever we get such a power, its value is the argument of the logarithm a. Okay, now let's consider this e to the power of ln3. Okay, so here, as I said already, ln is a natural logarithm, its base is e. Here the base is e, and the base of the logarithm at the exponent is also e. So then what is the value of this power? It is equal to the argument of the logarithm, that is 3. So therefore the value of this e to the power of ln3 is just 3. Okay, now let me plug in 3 for this one. Negative 2 divided by 2 times 3. Then we get f prime of ln3 equals to 3 negative 2 is just 1. 2 times is 6. Clearly it's a positive value greater than 0. Okay, when I take a random value in this interval ln2 comma positive infinity, so the value of the first derivative is positive, that is slope is positive. Since the slope is positive, in this interval ln2 comma positive infinity, the function f is increasing, and we find this interval ln2 comma positive infinity in answer choice C. The correct answer choice for this question is C.